Hi, welcome back to this YouTube channel. In this video, we're going to look at how to find partial derivatives using chain rule, okay? And this is a different type of problem where we look at more complex functions and then how we can use chain rule to still find the partial derivatives of such kind of complex functions. So let's just get right into this video. Now, our function z, which is a function of f and y, of x and y, right, is given as this, okay? And now we are asked to find the partial derivative of z with respect to x, okay? Now, notice that z is actually a function of what? X and y. So we can literally write this. And then x is a function of t, while y is a function of t. So now, to find del z del x, rather del z del t, which is what we are looking for, we have to go through either the first route or the second route, which is through x or through y. So therefore, the partial derivative would be del z del x multiplied by what? Dx dt. Then plus the second route, which is del z del y multiplied by what? Dy dt. Okay, so this is how to find the partial derivatives. Now, the only difficulty is actually learning how to differentiate the functions properly. So let's look at each of the function differentiation, right? So differentiation of z with respect to x. How do we do that? Now notice that. So let's break this function down. X squared y ln y plus what? 2x. Now notice that this is basically the product of two functions, where the first function is this and the second function is this. Now, once you know this, you should know definitely this is going to be product rule in order to what? Differentiate such function with respect to whatever variable you're looking at, okay? So this is going to be chain rule. Right, so let's just focus on finding the derivatives here. So we know that what we are looking for del z del x. Now what you have to do is what? Using the product rule, it means you leave the first function and you find the derivative of the second function with respect to x, plus you leave the second function multiplied by the derivative of the first function with respect to x. Now you have to find each of these derivatives. What is dv dx? Now don't forget, okay, so before we go into this, notice that your u is basically giving us what? E raised to power x squared y. And your v is giving us what? Ln y plus what? 2x. So now we want to find dv dx. So how does that work? Which is the differentiation of this function, which is just, again, notice that what? This is two functions nested together as one, which is the first one is the ln, which is the external function, and the second function is the internal one. Now, this is going to be chain rule in order to solve this problem. Now, dv dx, we are going to use chain rule to differentiate this, which means we'll differentiate the outer function or the external function, which is ln, multiplied by the derivative of the inside function, which is y plus 2x. And all of this with respect to x. Now, derivative of ln function would give us 1 over whatever that function is. That is how we find derivative of ln function. We have to now multiply this with what? Derivative of the inside with respect to x. Now, find the derivative of y plus 2x with respect to x. Derivative of y is 0, plus derivative of 2x is 2. So you have to multiply by 2. So the answer to that will be 2 plus 2 over y plus 2x. Next is you need to find du dx, right? Which is derivative of this one. Now, this is what exponential function. Again, this is going to be chain rule because we have the first function, the external one is e, and the internal one is what? X squared y. Okay, so you find the derivative of the external function multiplied by the derivative of the internal. Now, derivative of exponential function is the same as the exponential function, right? Exponential of whatever is inside the exponential function, which is x squared y. We have to now multiply this by derivative of the inside function. And what's the derivative of the inside function? With respect to x, that would be 2xy. Okay, so derivative of x squared y with respect to x would be 2xy. So therefore, the answer to this is 2xy over e raised to power x squared y. Oh, sorry. There's no division here. It's just 2xy e raised to power x squared y. Cool. Now we can find del z del x now quite easily, which is u times dv plus v times du. So let me, which is equal to v times du. What is du? 2xy e raised to power x squared y. Okay. So so basically you can bring this together to give us you can just, because we know that what e raised to power x squared y is common to both sides, so you can just bring that out and get the derivative of this function with respect to x. So this is del z del x. Now similarly, we're going to find del z del y. So let's just do it across here. So del z del y, we also need to find this. Now, exactly the same way, we need to find the derivative of u. So we're going to look at this function again as product of two functions, u times v. So which means that what derivative of z with respect to y would be u multiplied by what derivative of v with respect to y plus v times derivative of u with respect to what y. So using product rule, right? Don't forget that what your u is still e raised to power x squared y, and your v is still ln y plus 2x. Okay, good. Now let's find the du dy, right? The u dy is derivative of this with respect to y. Again, chain rule, which will be differentiation of the external function, which is the exponential function first, multiplied by derivative of the inside with respect to y, which was just x squared. Because remember, x squared is now acting like a constant in front of y. Okay, good. So this would give us x squared e raised to power x squared y. Okay, good. What about dv dy? Okay, so dv dy is the next one, which is derivative of this function with respect to y, which is just derivative is chain rule again. Derivative of what? Lane function is 1 over whatever is inside that lane function, multiplied by derivative of the inside with respect to y, which is just 1, because derivative of y will be 1 plus derivative of 2x, which is 0. So you just have 1 over y plus 2x. Okay, good. Now that we have this, let's put this together. So don't forget, we're looking for del z del y, which is u times dv, which is 1 over 1 plus 2x, plus v times du, which is x squared e raised to power x squared y. Okay, good. So this is del z del y. Now the rest is easy. Now that we found this, what is left? Remember, when we come here, we've gotten this. What is left is dx dt. So we can quickly get that. Dx dt is just derivative of this function with respect to t, which is just cosine t. And then dy dt is also very easy, derivative of this function with respect to t, which is just minus sine t. Now, you are ready to put everything we have all together into one, right? So what do we have? We are looking for what? So so don't forget what we are looking for. We're looking for del z del t. And we said this was what? Del z del x times dx dt plus del z del y times dy dt. So let's put things together. Now del z del x, we got it here. So we use that e raised to power x squared y bracket 2 over y plus 2x plus 2xy ln y plus 2x. Now this multiplied by what? Dx dt, which is just cosine t. plus, okay? Plus what? Del z del y, which is what we got here, which is e raised to power x square y. Also, we can put this inside bracket. What is left is y plus 2x plus x square ln y plus 2x. So where am I getting? I'm getting it from here, right? So look at this, right? This is the okay. All right. So sorry for the shortcut there. So basically, when you want to finish this problem, you could just basically bring this function out of the whole thing, and then you have 2 over y plus 2x times cos t plus 2xy ln y plus 2x times cos t. Then you come to this side, we have minus sine t over y plus 2x minus x squared ln y plus 2x. So let me shift a little bit to this side so that we can see the whole frame. 2x sine t. So I'm just expanding this and factorizing e raised to power x squared y out. So this will be the solution to the problem. Right now, if you like, you could substitute what x is, what y is into this problem, and then you have even a bigger expression, but this is fine. This is the solution in terms of x, y, and t, right? So if you like, you can substitute x equal to what was x from the very beginning. X was sine t, and then y was cosine t. You can substitute those to have even a bigger expression. What I mean is, let me write the first few terms. So the first one will be x is okay. So basically, what you can do is you can substitute x and y into this particular expression to find the whole of this expression in terms of t, right? So which means we are going to substitute sine t for x and then cos t for y, which is this. So x squared will be sine squared t, y will be cos t. Then inside this bracket, you now have 2 over y is cos t, don't forget, plus 2, x is sine t, right? And you continue to do this until you get to the last term, which is x squared, which is sine squared t ln cos t plus 2 sine t, then times sine t, right? Right? So times sine t, right? So you can do this in terms of t on everything that you've written. So that is basically how to find partial derivatives of a more complicated problem. So let's zoom in into this problem again. Or what we started with was this function, which is actually difficult to differentiate. It takes time, and you've seen all the steps we've taken. So just be patient with yourself when you are working on such kind of complicated problem and see the problem through. So I will see you guys in the next video.